Ladies and gentlemen, help me welcome Dr. Farouk الباز.
مساء الخير عليكم جميعا. Thank you very much for the delightful introduction. I'm pleased and honored to be here with you today. And what I wish to do is to convey to you some of the excitement of the exploration of space, the way we have felt it as individuals working with the space program. And I will limit my discussion this evening to just two things, the moon and Mars. As if this is just a little thing. And in reference to the moon, I'd like to convey some of the most important things that we learned from the Apollo explorations of the moon. And that comes down to the following: that the moon and the Earth were formed in the same instant of time. They were created in the same exact period of time. And from our geological understanding and measurements of rocks and mineral and compounds in it, it's exactly 4.6 billion years ago. Both bodies were created then. As we know that the Earth is evolved throughout that history and changed considerably and is still changing today. However, the moon actually was frozen in time since about 3 billion years ago, meaning that it evolved like the Earth for about 1 billion and 1.6 billion years ago, and but then it stopped evolving. And to us, this is fascinating. And the importance of that is the fact that we can look at the moon as if we're looking at the early history of the Earth, because the moon has not changed. There is no atmosphere on the moon. There is no water on the moon. There are no new deposits on the moon, meaning that what we see on the moon today is something that was born and grew and stopped about 3 billion years ago, meaning that we can look at the early history of the moon from 3 to 4.6 billion as if it is the early history of the Earth, because the Earth and the moon went through the same process. And that is a very important thing for us scientifically, because we cannot see the early history of the Earth, because the Earth has changed and it still changes today by wind, by water, by faults, by volcanic eruptions. All kinds of things happen to the Earth to produce new deposits and new features, and therefore this is a very good thing for looking at the early history of the Earth. And then we move into Mars and we find out that there is indeed quite a bit of relationship between the Earth and the Moon, between Mars and the Moon and the Earth, very much like the situation of the Earth and the Moon, but even more so, because Mars is still changing today. And it looks to us today very much like the deserts that we are familiar with. The surface of Mars is very much like the Arabian deserts, all of it, like the North African and the Arabian Peninsula desert, because the history of Mars is nearly equivalent or identical to the history of the desert. Meaning what? Meaning there was quite a bit of rainfall and all kinds of changes due to the rainfall. Rivers formed, lakes formed. There was quite a bit of transport by water of material and deposition of this material, formation of new features, and then everything stopped and there is no more rain, and then the wind takes over. And the wind moves the particles and shapes sand dunes and so on. So on Mars you find sand dunes very much like what we find here on our deserts in here. Actually, the largest dune field that we know of is in the north polar area of Mars, not the Rub al Khan. No, there is a bigger dune field on Mars. So this is what I really would like to show you, and I will do that by showing you images. And my friend here is going to help us start the...
Slideshow.
To view.
That's it. Okay, and here is our first look at the gorgeous moon, which we once in a while we look at it, and this is the way it looks. And when it is قمر 14, it is the full moon, and we see these dark areas and light areas. And this is actually a kind of a division between the different surface rocks on the moon, the dark ones and the light ones. The first individual to look at the moon by a telescope was Galileo, and he looked at these and he thought that, that's very much like the Earth. All of these dark places are kind of flat and smooth. They must be like the seas, and he called them Maria for seas because he is Italian. And then, so all of the white areas, he called them the highlands, and he called them the Apennine Mountains, the Apennine Mountains, and the Alps, and so on. So because he wanted to make the correlations, and that division and the classification was very good, except for the fact that we're not really seas and we're not Maria, but we still call them Maria, but we know that they are formed by volcanic deposit. They're all basalt covered the deposits. So this is the basic definition of the surface of the moon, and in addition to that, we see all kinds of craters on the moon, and the vast majority of craters are the ones that are the result of meteorite impact. A meteorite flies near the moon and then gets struck on the surface, and it forms a hole in it, and that's all of this, like the ones on the right side of the screen. But there are also some calderas or volcanic rocks where the volcanic material comes up to a specific place and it forms a crater like that. So there are different craters on the moon formed by different processes, whether impact or volcanism. This we knew before the Apollo missions, and then here we have the Saturn V launch for the first Apollo mission, Apollo 11, and then we have the missions go to the moon in a specific shape. The first one is a spacecraft that actually rotates on the moon, stays in orbit, and this is called the command service module, where the 3 astronauts can ride in the piece of the module on the right side, this the spindle-shaped one, and all of the rest is the equipment as well as the power that is needed to propel. And then that one stays in orbit around the moon. It does not go onto the surface. What goes on the surface is the second spacecraft, which is called the Lunar Excursion Module, the one that actually lands on the surface of the moon. The astronauts used to call it the spider because of the legs that has this like this. And the spider is the only one that lands on the moon. The top of the spider goes back and links with the one that stays in orbit, and this is how the mission is completed. On the surface of the moon, we had the astronauts take all kinds of equipment. In the first missions, we did not, but in the later missions, we had astronauts carry a lunar drill, so they can actually drill through the soil and take samples so that we can see different variation in the different layering of the soil, because on Earth we have different layering, and what is on the surface of the Earth is not exactly what is beneath it and so on, because even in the desert right here we can see some sand on top, but beneath it, it might be something that's very different, like fertile soil or little broken rocks and so on. So there is quite a bit of variation. And in the last 3 missions, they carried a rover, a little jeep that they used on the moon to go from place to place, and it allowed the astronauts to go as far as 7 kilometers from the landing point to the places where they wanted to sample different types of material within 7 kilometers of a radius of 7 kilometers, and the 7 kilometers was defined by the fact that this is the only the fastest distance that astronauts could actually walk back. We wanted for the missions to have a walk-back capability, meaning that let's say that the lunar rover did not work, or it took them all the way to the site where they wanted to sample, and then something happened, and it no longer can bring them back. Which we had enough oxygen with the 2 of them so that they can actually link with the 2 of them and walk back to the lunar the landing module, so that they can be saved this way, meaning that they had to, the maximum distance they can travel is 7 kilometers, because this is how much oxygen the two of them carry for the mission. So the rover would take them up to 7 kilometers, and 7 kilometers were very significant. So the lunar surface, you can see that at least all of the tracks, all the roads that were left by the lunar module, and we know that these tracks will be there for thousands of years because there is no rain and there is no wind. So these tracks will if some humans go back to the moon to take pictures of these landing sites, we'll see the same tracks over there because the moon's surface does not change that much at all, even though the surface of the Earth will change because of rain, because of a dust storm, because of sand movement, but not on Mars because there is no atmosphere. And the astronauts were able to get very far from the landing sites, like up to 7 kilometers, to sample big pieces of rock. And like that one, and particularly this one, was a very large piece that landed from a very high level. And we used to, particularly in Arab countries, I tell them that that particular rock reminded me of the part of the poem that said جلمود صخر حطة من علي وحطه السيل من علي. So this is a piece of rock that went down through water that is pushed it down. But on the moon there is no water, so the only way to bring that piece of rock from higher altitude to lower altitude on a surface of a mountain is moon quakes. So the moon has, very much like the Earth, has quakes on it. When an impact happens on one part of the moon, the other surfaces nearby would shake a little, and that would cause moon quakes. And we use the moon quakes to measure the thickness of the crust of the moon and figure out the hardness of the layers beneath the surface and so on. So we utilize that shaking motion very much like what we used in geology of the Earth when we study the moon. The rocks that the astronauts brought back are very much like the Earth rocks, but made from different composition. There are a lot of people that say that the missions to the moon and so on were fake. There was no such thing. It was really done in a Hollywood space, and with there was all the flag was waving, and the such and such was this and that. All of this is nonsense, because the one thing that we know for sure is the fact that the astronauts brought back rocks, the likes of which we do not have anywhere on the Earth. These are rocks that were formed like the Earth rocks, but compositionally they are completely different. So you can chemically figure out exactly the difference between some of the moon rocks and the Earth rocks, even though they're formed by the same process. And we cut thin slices through them and look at them the microscope, so we can see all the details about them, and we can even find some of the glass spherules and the lunar materials in the lunar soil, and we see tiny little impact craters on them, so that the impact craters can vary from several hundred kilometers to sub-millimeter, tiny little craters on glass spheres. One thing we assumed way back in the 60s, and I wrote a paper about it in 1967 or something, to say that there were volcanic eruptions on the surface of the moon way back then, and volcanic eruptions that included the rock called basalt. And some of these volcanic eruptions, along with the melt, along with the magma or the lava that came out, there will have been some gases, and with these gases there would be some water. If that is true, then the water would have, or the gases would have made a temporary atmosphere, and some of that temporary atmosphere would have reached the polar regions. And since in the polar regions there are areas that are permanently shadowed, they never see the sun, then they will be extremely cold, and these gases, with them a little bit of water, would freeze and become particulate matter. And this was proven by the Japanese spacecraft that we had not too long ago with an impact in a permanently shadowed area on the lunar South Pole, where they analyzed the gases that came out from this blast, and they found a lot of hydrogen molecules, meaning hydrogen coming from water. So indeed there was, at the time of the formation of these lunar materials, there was water coming out from the lunar interior, and it is now in the shape of tiny little crystals mixed in with the soil, only in permanently shadowed